Just a quick little side note before we finish up this example. So you'll see that this is exactly the same example as we did in the previous video. I've just erased the stuff. Notice in our induction step, I used a direct proof. We have more tools in our toolkit, right? We have a proof by contrapositive, we have proof by contradiction, etc. So you don't have to use a direct proof if you don't want to. In fact, what we could do is erase this thing and use a different proof technique to be able to show this induction step. So you don't have to use a direct proof, you can use something else. So here, let's go ahead and use a different proof technique to try to show our induction step. So let's try a proof by contradiction. So again, I'm declaring in search of a contradiction. I want to, this proof technique, assume my hypothesis and not my conclusion, because remember that's how proof by contradiction goes. You assume P and not Q, and you try to derive a contradiction. Okay, so proceeding in search of a contradiction, I've assumed my hypothesis and I assumed not my conclusion, that this expression is not divisible by 3, and I somehow want to derive a contradiction. So again, we gather all the information that we know about this statement right here. This thing is divisible by 3. And I've just used my definition again to write down that that's what it means to be divisible by 3. And then the rest of the proof actually proceeds very similarly to how it did in the previous one. So we take a look at this part because we assume that that is not divisible by 3 and see if we can derive a contradiction. So we notice if we go ahead and expand that thing out just like we did last time, this is looking very familiar. We can cancel our 1s. And I've rearranged that, and once again, I've assumed that k cubed minus k is equal to 3t, so I can substitute that in right here. And what have I shown? I have shown that k plus 1 cubed minus k plus 1 is equal to 3 times some other number. But hang on a second. That means this number is divisible by 3. And we assumed that is not divisible by 3. That is a contradiction. So contradiction, our assumption that this thing is not divisible by 3. So you can see that the heart of the proof really hasn't changed. We had to take this expression right here and then rearrange it and use some other information that we gathered. But I just wanted to show you that you didn't have to use a direct proof if you didn't want to. You could use something else like proof by contradiction to be able to accomplish the same thing. But in any case, usually when people do proofs by induction, they use a direct proof, but you don't have to, especially if a different proof technique is going to be easier.